Not going to work. Is it necessary to put a type name there? There's a type name here as well. I don't believe it. Would I not have a note? Well, tell me this then. Your list base defines node. Struct node in list base. It's public. We derive publicly from list base. Node should be a type that is defined here. And if node is defined here, why is it not known in const iterator? I've no clue. So I had to add that here, right? I mean, try it again. So for some reason it doesn't know that. Okay, so we... Oh, wait a minute. Actual test. Well, I already had this, but... I have absolutely no idea why node is not defined here. I mean, it's just part of the base class. Maybe I should... Oh yeah, then I have to add the base class in front of it for some reason. I don't know why, actually, but... And therefore I decided to make a type def, or using. But surely that's not necessary for outside of the iterator clauses. So I would say that here I can just use node. And then it says node does not name a type. Seriously, why? So I have to do node type, which means that node type must be defined then not here, but here. Or are you telling me that it need to be defined in both? Yeah, just like the value type, probably. Okay, so I do this again. A little bit by now we just check everything. No declaration matches. I mean, now I get to line 263. Seriously? So that does work. So we can define no type here, and then it is known here. Yeah, just like it was before. I didn't have a node here either. I don't understand why types from base classes don't just inherit. But okay, whatever. So the latest error is that no declaration matches previous. Candidate is const iterator returning. This one returns iterator. It tells list base value type previous const. And this one. That doesn't make any sense. Value type defined here. I think it just doesn't understand that this is a type. The return type of previous is not the same type as this one. So I want list iterator to be the same as list base iterator. For some reason I have to. Nah. Pause. Wait a minute. Yeah, I forward declare iterator here in list base, and then we use that for the previous, which is kind of nonsensical because then we define it in list, but that's not the same iterator as the one from list base. Apparently, I can only define it here, or can I move the iterators to the list base? Need a value type. I need a value type. Not possible then. Oh, what am I saying? Value type is defined here. You're now telling me that I can move the... Oh, of course, yeah. No, never mind. The only problem is was the default allocator. So we can just move the iterators to the base class as well. List does not name a type. Oh right, yeah, I made it list based now. Node type does not name a type. So now I have to define that. Wait a minute. The thing was defined as this. List-based node. You can just use node now. Now we're in list-based, so there's now node type is just node. Iterator does not name a type. Thought so. No declaration matches previous again. So previous, the value type in list base, returning an iterator. Candidate, something returning const iterator. And this one. Iterator, what is this? It's a list-based iterator. But it should be the same type, so what is it talking about? It still doesn't want to do it. So, okay, I guess I won't blame it. I'll use list-based then as return type as well. Yeah, I moved it there, so yeah, I mean, now I might as well. My AS. Got two template parameters, but require one. For what? Oh. Accept here, of course. Allocator was not declared. Yeah, but this must be list based as well. Oh, that's yeah, never mind. It's because it is an explicit constructor, so I just repeat the return type here. which we just changed. Invalid use of member list alloc in static member function. I go to admit. I admit defeat, I mean. It's not static because of the use of alloc. Valid declaration. What? Valid declarator before const. Oh, list doesn't exist. Is this a problem? This is a problem. What? No. What? Well, it's semi-problem. And that pointer is currently defined in... No. Huh? What? Wait a minute. Pointer is defined in const iterator. This is const iterator. I mean base node, of course. Base node is defined in list, but it does not use the allocator, so I might as well move it to the base class. Put it at the beginning, the end, where do we put this? Sorry, base class, not the iterator. Which means that we move taint as well. Maybe even untaint. Let's move both of them to the base class. Wait a minute, who's calling taint? I added this to... Okay, I'm so confused. It's nonsense. Probably private. Do we have already something private here? No. That is, that's still the const iterator. I have nothing private. I'm gonna add private at the top. List base. Oh, you have to define the node first. Node is defined here. Is tainted. Might as well add it here. Make this public. This becomes a node. Node type. Yeah, and I did something stupid here. I added the base node to the value type. That must be here as well. I'm gonna add that actually at the top. Which is not possible. It has to be defined below node. Again. Gets its own private because this is a member variable and these are member functions. Now I'm at it anyway. I decided to make this a binary OR and this a binary AND with the inverse of that. Although I probably better make it an unsigned long then, or maybe even make sure that it is an unsigned int pointer type. What the fuck, how would you normally do that? That doesn't work. Need the last bit reset, so that is that thing -1. That is -2 then. What am I doing wrong here? Yeah, that must be correct. If not, we'd crash. So I don't. Okay, so I don't know what I was doing. So keep compiling. Base node was not declared in this scope. It's kind of lame, if you ask me. Now next is going to tell me the untainted does not exist. Nah. Base node was not declared. Overlooked that one. Base node was not declared. Deja vu. Base node was not declared. No. List base T. Base node. Might as well continue here. Invalid declarator before const. Compile. Still not. I want the list base to be above the list allocator things. This is list base. Value type next. Let's put the, wait a minute. List base value type next. And you're talking about, I don't know, man, where to put it. What is a logical place to put this? Put it here. No type does not name a type. Instantiation in instantiation of a pushback. Quite from here. Base node is private within this context. Declare private here. List base node, and that is being used in pushback. So that would be this one. It's not an improvement to put these file line numbers there. Okay, this is a member function of list. List is derived from list base. List base has base node. If I make it protected, I shouldn't even need this prefix, if you ask me. So I added the prefix everywhere because it was private, and then it started to complain about something else. So yes, obviously this must be protected. Quite from here, error base node. Now it's protected. What? Declared protected here. Yeah, I know we're declared protected. Why can we not access that? See, this is a member function of utils list. And list is derived from list base. So we should be able to access its protected members. I am highly confused. Okay, new trick. Untaint was not declared. So untaint, it's again, what the hell? I have no clue. I just don't know when this pointer is required. So When I run into weird errors, I just add it. So that works sometimes. Oh no, attained and untained are private. Okay, so it's possible that it says it doesn't exist because it's a private something of the base class. And then if you explicitly add this, it says, well, okay, you really want to access the base class member. I pretended it didn't exist, but now you're so specific, I have to tell you that it is private. Although I got the same thing with the base node. Probably this pointer is required anyway. But let's try... what the hell now? Instantiation of create node guide from inaccessible base of node is an inaccessible base of this base class, which now happens here. Oh yeah, okay. What type does the thing return? The allocator returns value type pointers, I think. We are inside list. I do have a value type. Let's start calling it a value type, and then I get the problem here, of course, because now I want to convert that to a node type. I don't know, show me the error first. There's no member data. Yeah, this is still code from Claude. It's bullshit. I have to finish this. Let me just make it compile first, I would say. So I wanted to try and remove at the very least this pointer. Nope. Needs to be there. Strange. Allocator traits construct. Have a look at what the hell that is. Construct. Must pass reference to the allocator and a pointer to the type. Do by P. If possible, construct objects of type T in allocated uninitialized storage pointed to by P. That's what just was returned from this thing. So nobody knows what the data is doing here at all. I would say this is just new node. By calling a construct, it's a single thing. If it was not possible, alloc does not have the member function construct, then calls new static cos void pointer p t standard forward args until or since standard construct add construct add standard forward. Okay. Yeah, P must just be type, the value type here. I would say. It's a good thing that we return a value type then. Although, no, I don't know. Anyway. Create node is constructed from a value. This is a bloody copy thing. What happened to emplace? Well, it is pushback, of course. So we have a reference to a T. Okay. No. This is going to call the copy constructor of a value type, which I don't have, I think, yet. Yeah, this is annoying. Normally I just double click on it and then paste it and then I can edit it. And apparently something got changed. Suddenly I have my errors like this. Instead of at the beginning. It does not highlight that one. Just have to remove tildes from the beginning. Suppose that is possible. Yeah, it should be the $1 here. Let me just remove the tildes from the beginning. That'll work. New node next, null pointer. Hello defiler. Oh, and Blackie. Hello my friends. I think in Black was testing if this was really live and I didn't see it and now he left and totally disappointed. It's always live, always. Okay. Well, hello my friend Blackie. What do we with the next thing here? We just add a new thing and it's created, but nobody knows where it has to go. Oh, this is just initialize it to some value because the AI thinks let's not initialize it. Well, I don't care about the values. Just create a node and then we fix the next pointers here. However, now the problem comes, you have a value type and I want to return a node type because I need a node type here. I mean, I can return a value type and I need a node type anyway. At some point we need a node type, yes? This is a node pointer. So I thought, let's do the conversion in create node. Then I never have to bother with that again. However, there is absolutely no way to get to the node because it's protected. Well, not in a clean way anyway. We can do it with a very dirty way. So I have a class value type and that has a protected node. So we can't just reinterpret cast it. We need to do a static cast to node and nobody has access to it except value type itself. So I could add something here which allows you to access node, but that would defeat the purpose of having it protected, I think. So I could add that here, but then make it private and then add a friend for the list class. The list class doesn't exist yet. I can add list base can be added as a friend, and by then I'm like, yeah, what? I'm gonna make this protected just public. What is a reasonable clean way. Okay, I see you, Blackie. Oh, I should leave as well, actually. I shouldn't even have started to stream. I should have gone to bed an hour ago. But it felt like it. Is a class that contains a class definition not by definition a friend, or is the other way around? I think the class value is a friend of list base, but not the other way around. However, the template is known by its name list base, so you can add friend class list base, I think, without having to talk about templates. And then we get an error in 3.16, so apparently that worked. So now list base is a friend, so I can call a member function on the base class of the current class, and then have that convert to a node like that. Good to node. Although it's not really a conversion, it's just a cast, like a const cast. I'm gonna call it a node cast. Instead of const cast. I bet it needs a this pointer again in front of it, but I just refuse that. So I mean, I want to see the error first before I start to add this pointers all over the place that are not needed. And then I need to add a node cast to the list base class, which then, well, which is a friend at the moment. That's a friend of my value type. Which means that we can add here node cast, which is going to return a node pointer being passed a value type. And I'm pretty sure that thing is static. But even though the list base is a friend, we can still not access this the base class. I don't think so. Well, we'll just try it. So we do a static cast to a node pointer from value. And then the first error is in instantiation of create node, required from, create node, required from here, node cast was not declared. Okay. So yes, must have this pointer pointer. And then we run into what a lot of white space here. In instantiation of static, where the hell does a construct? Oh, wait a minute, never mind. Construct, blah 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 blah. Required from utils list push back. Create node required from here. The error is there. Oh, it was red. I could have seen it immediately. Now matching function for call to construct add something. It's trying to construct a value type by passing a data reference. Indeed, we don't have that. So let's add that. So that means that I'm trying to, what was it? Construct a value type by passing a value. Wait a minute. I have that here. I should have that here. That says that we can construct a value type from a data type. T is data, so okay, let's read it. In instantiation of static construction standard allocator trace standard allocator up construct allocator type up. Arguments with up is standard list based value type. Arguments is data const reference. TP utils list based data value type. Allocator type is required from here. No matching function for call to construct utils list based data value type pointer reference const data reference. Candidate template class TP class dot args const expression declaration type new what the fuck standard construct add blah 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 construct add template argument deduction substitution failed in substitution of with that and that. Where's my new error? Yeah, this is the real error. And then I hope it says candidate. Yep, candidate const expression data const expression data. That's my copy constructor. Inherited here. Yeah. An inherited constructor is not a candidate for initialization from an expression of the same or derived type. Let that sink in. Well, I'm not exactly grasping it, but it seems to say that that it refuses to use it. So we just have to spell it out, I guess. No, I can't do that. Because I don't know what the constructors are. What the fuck? What is the use of this using if you can't use it? Yeah, whatever. Template, type name, args, value type. Args, args, t, standard forward. Okay, I'm definitely missing something here. Is it here or there? Well, I'm guessing here. Forward. It's like a magic incantation that I just can't remember. I'm just putting the dots at random places, seriously. And then the chance is so big that it goes wrong that we'll just use a search for previous times that we used that. It must be, the dots must be after the closing thing. Function view. I'm gonna try this one. Yep, so it is this a universal reference, args, sends forward, dot behind it. And then of course the args itself are like type name dot. Type name dot. I got it right. No, I did not. I did not get it right. It's completely nonsense what I have here. I mean, it wasn't even a type. So this is right. Compile the master, the Lord. Just so you know it. What was that thing? My memory is so bad. Continue here. Continue watching, and then there is simply. I think I have to reload it before the page works. It's completely broken. Completely broken. They removed like everything. This one. Overlord. Yeah. That's what I want to hear next time, Blackie. Overlord Carlo. In other words, it compiled. I couldn't remember the word overlord, that's why I went to Netflix. It bloody runs as well. This is my cue to stop streaming and go to bed, I think. It must be possible to insert a new element before any given iterator, including begin and end. Yes, the list itself might be needed. Okay, but that's just a normal insert. I almost finished. Yeah, all of this works. Can make a doubly linked list. Push back works. This exists. Don't ask. The size of my iterator is equal to a pointer, single pointer. Begin works, of course. Dereferenced iterator can be assigned to the data object that you are used here, as you would expect. We can use standard next and standard previous on iterators. And this is new, I think. Yeah, just having the value type, I can advance to the next object. So that's kind of weird. This is totally not standard that you can do this. So normally if you have a dereferenced iterator that gives you the value type, then you just have the value type. There's no way to get the next or the previous element in the list. But we do have a previous and next member function that just gives an iterator back from the value type. Ta-da! Exclamation mark. Furthermore, I can test if an iterator is the end of or begin iterator without having access to the list. That's about it. And I did not implement anything else, so it's really like a lot of work, I think, to complete this. So this is the list base, which defines the node with the previous and next pointer. And contains the base node. So the base node pointing to itself means that we have one node, but that means that the list is empty. And I have a value type, which is derived from the user value type, but also includes a node. Therefore, if you have the value type, you can access the previous and next pointers. And then here we define the iterator, which is pretty standard actually. But it has an is end and is begin that you can use without having the list. Using a is tainted trick, where is tainted means that the pointer is odd. So just normally all pointers are aligned with by 8 bytes or something, and I just add one, so it's definitely not a pointer anymore. Or could be a pointer pointing to a character, but it never points to a character, but it points to other pointers. Now, iterator is just defined in terms of the const iterator. And then we have the list implementation itself, which has a lot of stuff which is not implemented yet. A lot of stuff. Like the copy constructor, the move constructor, the assignment operator, the move assignment operator, front not defined, back not defined, back not defined, begin not defined, begin not defined, C begin not defined. I defined the end, however. R begin, never heard of it. R end did not define that. Empty was defined. Size is defined. Max size is defined. Yay. Clear, not defined. Insert, that's my next thing. None of the inserts or erase are defined. I've only defined this one, pushback value. This one is not defined, and placeback is not defined. Pushback not nothing. Totally not defined. Never heard of it. Sorting. Oh my god. So yeah, that's a lot of work. All of those member functions have to be defined in order to make it a real standard conforming list. Not looking forward to it. But we have AI. I'm going to ask Claude to do it for me. It will fail, but then I have a template that I can quite quickly fix, I think. Anyway, now I have to go to bed. Good night, everyone.